Continuing with topic 11.1, permutations. These are permutations with repeating objects. Consider the number of four-letter arrangements that are possible using the letters from the word pool. If all of the letters were different, the number of possible four-letter arrangements would be 4 factorial, or 24. There are two identical letters, O, which, if they were different, would be arranged in 2 factorial ways. So the number of four-letter arrangements possible when two of the letters are the same is going to be 4 factorial divided by 2 factorial, which is 24 divided by 2, or 12. So the set of n objects with A of one kind that are identical, B of a second kind that are identical, and C of a third kind that are identical, and so on, can be arranged in n factorial divided by A factorial times B factorial times C factorial different ways. Well, let's see this at work. Here we have repeating objects. How many different 8-letter arrangements can you make using the letters of the word aardvark? Well, what we have is 8 factorial divided by 3 factorial times 2 factorial, which, if you used your calculator to evaluate, would be 336. There's 3 factorial because there's 3 A's, and 2 factorial because there's 2 R's, and 8 factorial because there's 8 different letter arrangements. Now, that's going to be 3,360 different possible combinations. In B, how many paths can you follow from A to B in a 4x6 rectangular grid if you move only up and to the right? Well, notice that there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 different steps to getting to the end. However, 6 of them are moving to the right, 4 of them are moving up. So 10 factorial divided by 4 factorial times 6 factorial, or 6 factorial times 4 factorial, will give you 210 different possible ways of getting from A to B. Here we are in your turn. How many different 5-digit numbers can you make by arranging all of the digits of 17171? Well, in A, first of all, there's 5 letters, so that would be 5 factorial, and it would have to be divided by 3 factorial, because there's 3 ones, times 2 factorial, because there's 2 sevens. And if you put that in your calculator and evaluate it, you're going to get 10. B. In how many different ways can you walk from A to B in a 3x5 rectangular grid if you must move only down or to the right? Well, when you're moving down, there's 3 combinations. When you're moving to the right, there's 5 combinations. So altogether, there's 8 combinations to get from A to B. So we will say 8 factorial divided by 3 factorial times 5 factorial, which is 56. And if you took the time to count the number of pathways to get from A to B, you would find it would also match 56. I'd like you to stop now and do the first part of the assignment, page 524, numbers 1 to 8, and then come back and work through examples 4 and 5, which is in lesson 11.1, part C. We are done, part B.